For the procedure, we are going to use the PET simulator that provided in our canvas. The distance between the charges was held constant on the first set of data. We're going to scale the amount of charges and distance between the charges, and we're going to do it for 5 times for 5 charges. The actual experiment will be executed as follows.
Table 5. We have here the gathering of data. For set A, we can increase the value of Q1 and Q2. It depends on the diagram that the other member did. Next, our force may either be plus or minus. In set A, the distance between the charges must be constant. Our goal here is to increase and record the value of our Q1 and Q2. We are going to record 5 trials. For our first trial, we have here the first diagram. As you can see from the diagram, Q1 is negative 7 microcoulomb and Q2 is negative 4 microcoulomb. As what I've said earlier, our distance must be constant. So all of the trials have 4 centimeters. And we need to convert that into meters. So 4 centimeters will going to be 0.04 meters. And for our force, the value of it is 157.282 newtons. Next, we have our second trial. This is our second diagram. As you can see from the diagram, Q1 is negative 3 microcoulomb and Q2 is positive 1 microcoulomb. Still, our distance is 0.04 meters. And our force value is 16.852 newtons. For our third trial, this is our third diagram. As you can see from the diagram, Q1 is negative 5 microcoulomb and Q2 is positive 2 microcoulomb. And still, our distance is 0.04 meters. And for our force value, it is 56.172 newtons. Next, we have our fourth trial. This is our fourth diagram. As you can see from the diagram, Q1 is positive 2 microcoulomb and Q2 is negative 3 microcoulomb. Still, our distance is 0.04 meters. And for our force value, it is 33.703 newtons. For our fifth trial, we have here our last diagram. As you can see from the diagram, Q1 is positive 3 microcoulomb and Q2 is positive 4 microcoulomb. Still, our distance is 0.04 meters. And for our force value, it is 67.407 newtons. So we have here our final table for set A. We have different amount of charges in every trial. We have the same distance and we also have different forces.
Gathering of data for set B. There will be 5 trials. For every trial, there will be a constant value of Q1 and Q2. There will be different distances and the value of force will depend on the FET. Same as the set A, it depends to the diagram of the other member did. For the 5 trials, our Q1 will be 1 microcoulomb, while our Q2 will be 6 microcoulomb. The distance between the charges should be in meters. and the value of force should be in Newton. For our trial number 1, we have the distance of 0.02 meter, while our force is 134.813 newtons. For our second trial, we have the distance of 0.03 meter, and our force is 59.917 newtons. For our trial number 3, we have the distance of 0.04 meter, and the force is 33.703 newtons. For our fourth trial, we have the distance of 0.05 meter, while our force is 21.570 newtons. And to our last trial, we have the distance of 0.06 meter, and our force will be 14.979 newtons. This is the complete table for table number letter B.
The experiment that we have conducted is all about the Coulomb's law, or what we call the inverse square of Coulomb. It is an experimental law of physics that quantifies the sum of force between two electrically charged particles that are stationary. The electrical force is conventionally called electrostatic force or Coulomb force between charged bodies at rest. During the experiment, we applied the Coulomb's law of experiment to determine the distance and force between the two charges and to determine the force on one point due to the several presence of points. We observe that the force between two charges particles is very dependent on the distance between them. It is because the electrical force between the two charged objects is directly proportional to the product of the amount of charge on the objects, and the distance between the two objects is inversely proportional to the square of the separation.
In conclusion of our laboratory experimentation, we were active in checking the existence of an electrical force between the interactions of two charged objects, as well as the proportionality between the magnitude of the force, product of charges, and the distance. So, the aim of this lab was to see how the distance between two charged objects influences the magnitude of the electrostatic force between them and to see how the different materials influence the force.